and I'm deliberately using an old radio, just because then you can see all the parts. I like to use digital modes, narrowband digital modes on HF when I do HF. I don't use voice. I save my voice to talk to you guys and gals. And I like to use digital modes. Now, today the sunspot cycle is at a minimum. So there is propagation, but it's poor, and you have to dig the signals out of the noise. So there's a rule in basic radio, even ham radio is subject to this rule, that you have three things. You have power, distance, and speed, that is bit rate. And even with voice, you can associate a bit rate with that. You can have only two. So if you want to go far, you got to take the energy and figure out a way to concentrate it as narrow a band as possible so you can go further. So for example, this is for round numbers. The spectrum for the human voice is about, it's 2400 hertz, but just for round numbers, it's 3000 hertz. I like to use the digital mode, the chat mode, because I'm a yakker from New York, I like to chat. Or in CW, we used to call it rat chewing, have a conversation, and I had a lot of fun with that when I was a kid, using Morse code. And that's roughly 30 hertz wide. So, what's the ratio of 3000 over 300? 30, excuse me, let's say that again. 3000 divided by 30, well I can't do that kind of arithmetic, but I can go 300 divided by 3, that's 100 to 1. So can somebody tell me, who recently had to pass the technician test, what's the ratio of 100 to 1 in decibels? Okay, yeah? What? 100 to 1, what's the best decibel? Oh, 20 dB, exactly. So effectively we have a 20 dB gain, which means the power density, the amount of power divided by the amount of width of the spectrum is more concentrated. It's not unlike a flashlight. You have a bulb, you hold it up and it lights up 360, actually 720 degrees, spherical degrees. Or you put it behind a parabolic polished mirror, you can focus all of that energy in one, a narrow beam. The analogy holds, it's the same thing. So, for me, it gives me the efficiency of Morse code, that is the economy of Morse code, 50 hertz for Morse code. You can't do exactly 0 hertz. That's physically impossible. See me after class and I'll tell you why. So 50 hertz wide. So 30 hertz, 50 hertz, it's a narrow band. So you can go much further. So PSK, CW is considered a weak signal mode. And typically with PSK we operate maybe 30 watts, 40 watts. And there are some people who use a lot of power and it just overloads the band and they're being, not good neighbors. Now, afterwards, there's an ultra weak signal mode developed by our very own Joe Taylor, K1JT, our very own Nobel laureate. So this gentleman started out in ham radio when he was 11 and fell in love with this radio stuff, which led to a career as a professor of physics, and he got a Nobel Prize in astrophysics. And he figured out that the pulsars, these stars, these neutron stars, when they revolve, are not little green men with their beacons. They thought it was little LGMs, little green men. No, he figured out it was a neutron star, and by measuring the slowdown of these pulses, I think it's microhertz, over a long period of time, he said, he must be losing energy due to gravitational waves. Yeah, I saw him at the 2014 AWL convention, one of the keynote addresses. This is ham radio, got him started. But recently I heard him speak saying that his work with pulsars led to an explanation involving gravitational waves, which led to the justification of spending $500 billion to build 2 very sensitive gravitational observatories. And that's so cool. So speaking about a ham radio success story, it doesn't get better than that. Anyway, so on with the demo. So I have 2 radios here. I have here, this is my first small radio, actually my second small radio that I bought. I like small radios because it's portable. So I'm completely self-contained here. I have my own power. I have my own antenna. dummy antenna. It's my favorite antenna. Why is that? Because I like to experiment with various digital modes. So I have two tables in the family room, and one table has one station, the other table has another station, and I tinker, experiment various things. It's also a great way to debug your stations. So this morning when I was doing the setup, if they can't talk to each other, I don't have a demo, but they can talk to each other, so we're good. So this is a 706, an ICOM 706 Mark IIG, I think vintage 20 years ago. Actually Adam was a toddler, maybe a little bit older, between 25 and 20 years ago. And upper sideband, lower sideband. And then the other thing which I have, and I recommend this as a wonderful starter device, audio interface. So it is a USB to audio interface, and it's about $100, maybe a little bit more, and with a cable, and plus it has a Vox circuit. So you don't have to fuss with rig control, keying it up. There is a circuit in there. When audio comes in, it keys the microphone. Okay. So that's what I recommend. Now, once you get familiar with the stuff, you can tinker. You can replace that with like a $7 device, but you have to know what you're doing. Now, this is called a USB signal link, and I have it in a hub here, and then I have another device here. It's a CAT control. CAT is computer. Well, actually, ICOM calls it something a little bit different. CIV. It's the protocol. So what it does is that the program that I'm using, FLDigi, continuously polls the radio. Hey, what frequency are you on? Hey, what frequency are you on? And conversely, and if you see over here, what do you see over there? Yeah. It is sensing what the radio is, but that's not too interesting. I can control the radio right directly from FLDigi, and let me maximize that. And there is a, if you forget what the frequencies for PSK31, see I set the mode PSK31, and so if you forget there's a book, and there, so I'm going to click on that, and there it is, 14070, and it should reflect on the radio. Is that? Yep. So there it is. Now I like this device because it gives me the happy blinky. If I don't get the happy blinky, something's not working. Now, that's a convenience, using rig control to control the radio from the computer, but the truth be told, the radio is sitting next to me, so you can do manual rig control. So that's a convenience. So just to get started, you have a basic radio, and most of these modern radios have a 6-pin data connector in the back. They call it data, but it really isn't. It's a direct tap into the audio line before, right after the microphone voice processing stages, right before the modulator. And likewise, the output of the demodulator goes right into the connector. So, look, Ma, no sound. So when I would travel, I can operate digital modes at night and not disturb my wife. But I don't need it because this is a very visual mode. I guess an elderly gentleman, Pam, would have, says, you know, my ears don't work. I can't hear anymore. I have a mode for you that allows no hearing. If you can see reasonably well, you can communicate. So, but I like the ambiance, the atmospherics. You know, the sound effects of movies, atmospherics. But also you can hear what's going on. You get some kind of a clue, but it's not necessary. Now, so I'm going to transmit a test message here, and that's, so what it is, and I'm going to zoom in over here. Apparently it's going to lose connections. Oh, come on. Stand by for technical difficulties. There we go. Okay. Okay, now it's charging. The reason why I like to have power to the laptop so it gives me full brightness. And we're in. Okay. Now, this is a track, PSK31 track, and it's actually being coded over here. Okay. So let me zoom in what that looks like. And So this is called a waterfall. So this is what you call it. This is a spectrum. Over here is low frequency, and I think you see the markings 0 hertz all the way up to 2,000 hertz. And we call it a waterfall because it's over time. So technically it's a spectrograph, but hands like to call it a waterfall. And if you look at the spectrum, there it is. And that's not too interesting. And you can look at the oscilloscope of that. That's what it looks like. And as an aside, you can record the audio waveform. You can turn on save to an audio file that it's transmitting, and then you can look at it at Audacity, which is wonderful, the Swiss Army knife of audio processing, and you can stretch it out and see what the wave looks like. It's very interesting. Okay, now, let me get this thing. Now,
So what are you doing there, David?
So I showed transmitting, but the flip side, which is more interesting, receiving. So I'm going to have another station here. There we go, and you can hear it. Now, is there a way of turning on the attenuator? Where's the attenuator? Okay, I'm going to turn up the volume. Okay. Oh, how did the noise blanker got turned on? That's
what does that do again?
okay. Now, what I want to show is, see, it's decoding. That's what I want to show you.
Because you're transmitting a message
I am
from
transmitting
there.
from over there. Now, the other parts of this thing is a power supply, and then I have a switch here, an electronics power switch that can switch from battery to power. So actually, I could be using external power, but if here at field they're using this, but if the generator conks out, it'll switch over to my battery. So that device turns the battery and this AC power supply into an uninterruptible power supply, UPS.
How much power?
Right now I'm transmitting 0.5 watts.
Half a watt.
And even then I'm overloading. I can hear I'm overloading. And so, but 0.1 watts was not strong enough, and 1 watt is complete overload. Yeah.
Are you able to use more than what the 6 watts?
You can, so.
You operate on.
Yeah, let me answer that. So these are ham radios. They're for voice they're rated at 100 watts. What that really means is 30 to 40 watts average, because the human voice has peaks and valleys. We're not talking continuously. But digital mode is a key-on mode, is 100%. So, let me see. It's one of the things I forgot to set. Let's see. Well, okay. This is set correctly. There's something called the ALC. Paradoxically, the digital mode is about data, zeros and ones. But to use these radios, you have to use the linear portion of the transmitter. If you overdrive the transmitter, it'll create distortion. And if you distort your bits, it becomes very hard to decode. In fact, impossible to decode. So, typically, if you want to run, let's say, 50 watts, maximum 50 watts, you set this thing for 100 watts, and then you set the audio level. And I could do this over here. Let's see what the audio is. Now, this device has two controls. TX, to transmit, and right now it's showing 1 watt, but if I increase the transmitter, it's showing more power, and the ALC is being tripped. ALC stands for automatic level control, and the circuitry in there is such that it deliberately distorts the audio signal not to cause splatter. But it's distorting our data, so you have to set it to the level such that it's not even turned on. And sometimes you could see right on the waterfall when people are overloading, they cause splatter, and they cause a lot of images. And I've actually taken snapshots of the waterfall and sent them an email. This is what you're doing, dude. Back off your audio drive. So as it turns out, you do it for two reasons. You don't want to distort the modulation of the transmitter. The other thing, you don't want to break the radio. If you run this thing for 5 minutes, 100 watts, it's going to get very, very hot. So you set it to the maximum amount of power without turning on the ALC. For this radio, it happens to be about 50 watts. So it works out, 50 watts, so 50% duty cycle. Now, Morse code is not on all the time. What is that? It's like 30 to 40% duty cycle. Lots of spaces. But here, when I'm transmitting it, it's key down. The other thing is maximum permissible exposure. You have that in your technician test. So if you're running 50 watts, you don't have to do a survey and analysis. You don't have to basically fill out a form. So 50 watts, you're safe. If you look on the chart, maximum permissible exposure, there's some banks that say, you don't have to do an assessment, an MPE, maximum permissible exposure assessment at 50 watts. You say, oh, 50 watts? I can do 50 watts everywhere, then I don't have to worry about it. It just also happens to work out. 50 watts is half of 100 watts of these 100-watt radios. Also, that's the setting. It's about where the ASC starts to trip. So it all works out. So in this case, too much is no good. Now, typically people use 30 watts, 40 watts. With FT8, people go like half a watt, like milliwatts. It's very, very interesting. Now, Robert's having technical problems with it. He has a movie, but he has trouble. He doesn't have power there, so I don't know what's going to happen. So, okay. Anything else I want to show? Oh, and by the way, let me do the other control. Let me do transmit again. Now, there's another control called RX. I'm in the wrong spot. I'm having trouble with the mouse here. Now, 100 kilohertz, 100 hertz, 1,000 hertz in the middle of the audio passband is kind of like the sweet spot. Now, RX, what does RX do? Well, no signal. Look, man, no signal. Now, I'm going to tune it to the other extreme. Well, here, is it overloading? Yeah, it's corrupting. But I'm going to back it down to the right level. Oh, you know what? I need to move the mouse. It went off frequency slightly. Where my computer was. Okay, there we go. And you to control, you adjust the amount of transmit audio and the amount of receive audio. Too much is no good and too little is no good.
So you have to get it just right.
Yeah. And so just at the point where it starts to decode. And by the way, there's a color code. It goes from blue to orange, to yellow, to orange, to red, and then it catches fire. Oh yeah, where were you before?
I was over by the.
Okay, that's fine. I can give you another demo. I can give you a demo just for you. So what else do we have here? We have the automatic antenna tuner. I can push tune and it will tune automatically. And what else is there? Oh, my favorite antenna, power supply. Anyway, so this is it. And you know, the newer radios have the sound card built in. Oh, the rig control, that is the frequency. You can change the modes. You can change the frequencies. You can upper sideband. You can basically control it. It's all built into the radio now. So I think this IC 7200 now, the 7300. That's a software-defined radio, and everything is all built in. In the manual, probably if you were printed out, weighs more than the radio. Certainly, it's a 600-page manual. Oh, I'm sorry. FL Digi, free software. You can download the software for free.
Does it work on all devices? Does it work on Apple as well?
Apple computers, yes. There's a version for that. There's a version for Linux, my favorite operating system. A version for PCs, and a version for Raspberry Pi, which is really Linux.
Is it free? Or
Yes, it's free. It's free and it's free. It's free like free speech. You can download it and read the code and make improvements and give it back to the community. And it's free like, it's free. Like, you know, we'll give you a hat for free, you know? It's free.
What is the name?
So free like free beer or free like free speech?
Name of the
FL Digi.
How would you spell that?
Oh, I'm sorry. FLDIGI. So Foxtrot, Lima, Delta, India, Golf, India.